Hey guys, I just wanted to go over, in case you guys were curious, the problem with the train, with the force and Newton's third law. As you can see here, I drew like these force diagrams for both the engine here. This is the engine, and this is the train, or the cargo that the train is carrying, basically. And so in this problem, you have at any given time, if the train is moving, it's applying some sort of force due to the engine, which is this right here that I'm circling. And the equal and opposite reaction will be made by the train. So the question is, how does the train then move? And so typically in these problems in physics, you do like a sum of all the forces. So all the forces acting on the train, basically, you have the normal force, which is just the opposite of the force due to gravity, which is down here. And then you have these forces, so that they all cancel each other out. So Fe equals Ft, Fn equals Fmg, so on and so forth, right? So that's a net zero. So we have to look closely at the wheel. So I drew this close-up of one of the wheels, and you have some sort of torque, which is what this tau is. And this torque being applied by the engine acts in this direction as it touches the ground. And so you also have this pair where you have an equal and opposite reaction with the ground itself. And so you have this F sub gamma, I just called it gamma, which is equal to this mu s, which is the static, it's a coefficient of friction that changes based on the material. So this is just some number. And that's multiplied by the normal force, and that's just the definition of the static force. That's not very important. But the point is, the equal and opposite reaction is going to push, so basically the ground and the train both, kind of like when you are, the example where you're on the earth and you jump, right? You applied a force on the earth, and the earth applied the exact same force on you, but only you moved, because your mass is much smaller. So F equals m little m a, and then F equals big M a. This a is going to be much smaller if it's touching the big M. Okay, so anyway, the exact same thing happens here, where one's pushing this way and the other's pushing this way. Okay? And so the only thing is the earth, the rail is connected to the earth, is just much more massive. So you have the exact same situation. So when you have the sum of all forces, you really only have this frictional force that's being pushed, that's pushing the train in this direction. So when all is left, when you add all the forces together, everything cancels out except this force. Of course, that's for each wheel, and then you have like a smaller version of that. As soon as these wheels start moving, it does get a little more complicated. As soon as these wheels start moving, they apply like a smaller version of that force, so on and so forth. But that's the general idea. I hope that wasn't too confusing. But that is why Newton's third law is not violated. That's all.